Welcome back to Leaving Cert Plus Geography. Today we're going to explore the theory of plate tectonics, which will bring us to our first essay focus. So first thing I want you to do is pause this video and write down two new Leaving Cert terms from the last class. Okay, so we had a good few key words in the last class that I highlighted. I've put two here and we're going to have a quick chat about them. So first one is the lithosphere. So the lithosphere is directly above the asthenosphere. It's part of the mantle and a small bit part of the crust. Your MOHO line then, this is the division boundary between crust and mantle. So if you got any of those two, well done. And if you wrote any other ones, well done also. So before we look into theories of plate tectonics, I want to quickly recap on the different plates that we have around the world today, because this can be part of a short question that accompanies a lot of the key terms we're looking at today. So this is us located here, Ireland, and you can see that Ireland is located on the Eurasian plate. Directly below the Eurasian plate, we have the African plate and the Arabian plate. Over to the left of the Eurasian plate, you'll always have the North American plate. Always look for Iceland, which is here. And you can see this line going down, this scar in the landscape, the oceanic crust, is your mid-Atlantic ridge, your mid-ocean ridge, formed when two plates pull apart. You have your South American plate here below your North American plate. You have your Nazca plate here. You have your Pacific plate, and this area here is your Pacific Ring of Fire. You have lots of earthquake activity and volcanic eruptions here. You have the Indo-Australian plate here, and again, you can see part of the Eurasian plate here also. So we're now going to move into having a look at the different theories of plate tectonics. So the first area we're going to have a look at is continental drift. And continental drift was a theory proposed by a guy called Alfred Wegener. So Alfred Wegener came up with an idea that all continents once upon a time were connected in one big supercontinent, and he called this supercontinent Pangaea. So according to him then, about 200 million years ago, they then went and they broke apart into two new continents, Gondwanaland and Laurasia. Also, according to Wegener, he felt that identical animal fossils were found on various continents, and for him, he kind of put together the concept that these continents then once upon a time were connected. He also found similar rock formations and mountain ranges were observed across different continents. So mountains, for example, in Northern Europe, they matched some of the rock formations in North America. So he believed that they were formed at the same time. Also, corresponding shapes of coastlines. So if you have a look at a map and look at Africa and you look at South America, it looks like they're two pieces of the jigsaw that once upon a time would connect. So the next theory we're going to have a look at is seafloor spreading. So we're going back to Iceland again, Mid-Atlantic Ridge, and so on. So this was accredited to Maurice Ewing and Harry Hess. As new magma is pushed up from the mantle, it pushes the crust to either side when the two plates are stretching, and this causes the seafloor to spread out. So a new land, new crust is formed when this occurs. So when you're thinking of seafloor spreading, again, as I said, think of Iceland, mid-ocean ridges, and then your mid-Atlantic ridge. This is an important point here also. So discovery that rock closer to the ridge then is younger than rock closer to the continent. So if you look at basalt rock close to the mid-Atlantic ridge, it's in and around 0 to 10 to 15 million years old. While basalt that is further away, this is close and it's closer to Europe and North America. This is a lot older and it's in and around 180 million years old. So what's happening here is as new crust is being formed, the older crust is being pushed away over time, new land is formed. So the rock that's closest to the mid-ocean ridge, this is going to be younger rock. Next area we're going to have a look at, and we've had a good look at this so far, is looking at convection currents. So this was something accredited to Arthur Holmes. He came up with this concept. Heated material in the Earth's mantle rises, cools, and sinks, and this causes then our plate tectonics to move. So convection currents, as we know, leads to earthquakes, volcanic eruptions, and the formation then of your fold mountains. Lastly, then, we're going to have a look at your subduction zones, and these occur when one tectonic plate moves beneath another. So the sinking plate melts into the mantle. This creates and adds material to the mantle, the magma content. Process then called slab pull. This pulls old seafloor then into your mantle. Just a quick recap then on some of the aspects from today's class. So I want you to have a quick look at the first question there. Can you name two theorists from today's lesson? So overall, probably the two most important theorists that we've come across today would be Alfred Wegener, which is your continental drift, and your Harry Hess. He is linked to your seafloor spreading. So how would you define the process of subduction? So subduction is when a denser plate sinks into the mantle, it melts and it adds to the material then within the mantle. So that's it for our first exam class focus today. Some of the key concepts we looked at: continental drift, seafloor spreading, convection currents and subduction zones. Tune into lesson 1.5 where we're going to look at some short questions, 20-mark questions linked to this topic. See you there.
If you like this video, you'll love our notes. You can get some for free in the link in the description of this video.